Hello, this is Sultan Mahmud, and this is my presentation for the final project, which is ElastiCube, a custom event-driven autoscaler for AWS. So the scenario, the problem statement, the scenario is that we have an e-commerce startup. It runs on production workload on a K3s cluster in EC2, and we have our CPU utilization. Like in peak hours, our CPU utilizes 70 to 80%, or off-peak hour it is not so low, like does not have any loads, but we have like flash sales, and then our traffic spike goes haywire in those times. So the problem is that we have a fixed pool of 5 worker nodes that is running 24/7. So it is expensive at night because our resources are being wasted due to low usage, and in demand peak it is like 100% utilization happening, and also our in flash sales it is like the load cannot be keep up with the resources. So here's the project objective. We have to monitor the cluster and what the worker pool that we have, and we have to make a decision and evaluate the rules when to what to do when the threshold are crossing, and when the resources are idle, and we have to provision new EC2 new nodes, worker nodes on demand. So, and then we have to integrate the nodes to the cluster, and then we have saves option. We have to have option for save scale down. So these are functional requirements. Like our scaling should be happening when the CPU utilization crosses 70%, and then we have when we have more than one pods, and it should scale down when CPU is less than 30% utilized. So and we have our bounds for maximum and minimum workers, and here are our node life cycle: auto provision, join cluster using token, so then cordon before node termination, and drain gracefully, and hard timeout is 5 minutes. So like when 5 minutes is over, we force terminate. And these are our non-functional requirements: reaction latency, fault tolerance, which is reliability, performance, security, and observability, which is we should be able to monitor the system. So this is our solution. So we are proposing an event-driven architecture with Prometheus, which will trigger lambdas, and so that and then we should have distributed state where we use DynamoDB to manage the state. We should have crash safety, and where we will be using write ahead log, and our system should be metrics driven, and it should be time aware. Here's the system architecture we have proposed. So this is our cluster. We have database, our lambda chaining we have proposed, where we should have separate lambdas which will be doing their own job only. So, and we have our event bridge, which will be triggering and invoking our lambdas as per the necessity. And here we have our S3 for bootstrap script. Here we are using secret manager for join token, SSM parameter for this, master IP, and CloudWatch logs for database. So here we have our scaling layers. So this is the scaling logic that we'll be following: 60% for off peak, 85% for peak, and flash sale window should get 30% in 3 minutes. Should detect flash sale window. And then here we have our last in first out scale down, and we have our multi availability zone round robin fashion scaling. And then we have implemented this predictive scaling using machine learning. So we have implemented Prophet model that forecasts CPU usage 15 minutes ahead of the scaling. Here's the training pipeline that this is how the model is being trained, and this is the lambda integration in the scale machine learning. So it falls back to reactive mode if model fails. So when model will be failing, it should fall back to this time aware solution. And then these are the results for our model test. So now we'll be seeing the live demo of this project, so how it scales and how it scales down. So here's our CloudWatch dashboard. So this is worker CPU percentage, worker memory percentage. This is lambda duration, and here we have master node memory, and then here we have CPU percentage, and we have logs here. So this is decision lambda logs, this scale down logs, and here are scale up and clean up logs. So let's do a walkthrough, basic demo walkthrough for this project logs. So let's do a test and run a CPU stress on this cluster. So I'm going to run this deployment to this CPU cluster, which is going to run 15 pods in the cluster, which will drive up the CPU percentage. So it is created. Let's check it out. Okay, so here we have our 15 pods are running. So let's check pods. So here we have our pods. All the pods are running. So a few minutes later, we can see our scale up has been finished, and a new scale up operation has been completed. So here we can see new IP and the status for this, and we can see the node count has gone from 3 nodes to 4 nodes total and 3 workers. And if we check, we have our cooldown activated, so it should it should not just scale up continuously. So there should be a cooldown period for each after each scale up. So now if we see the decision lambda, the CPU has been stabilized. It is below 70%, and the memory is below 50%, but the count has gone from 2 to 3. So there's 4 nodes and like 1 master and 3 workers. So now let's see how it scales down. Let's remove this deployment and check if the scale downs happen successfully or not. So let's delete I'm deleting this deployment to check if it is working or not. So now after deleting this the CPU stress deployment, we can see this scale down has been triggered. So let's check the scale down logs. So if we see this has been a scale down triggered here, here we can see this is our scale down. Our scale down has been moved from 3 workers to 2 workers, and here our scale down information. We have our steps here. We are training the worker, and then here our node name and like all the steps here are described properly. So now if we go over to the dashboard, we can see that our worker CPU has been stabilized, and our worker count also have been well, it is taking some time to update. So we can see that in the logs. So here we can see our logs. Let's go to the main logs. So we can see here that we have our the CPU has been stabilized, and then our node count also decreased from 4 to 3. Here's our worker count has been updated as well. So this is my demo. So here's our challenges and optimization. So one of the biggest challenges is race condition. So we have solved it using the distributed log, and here's our another challenge is spot instances of interruption. So we solved it using event bridge spot warning handler, and then we have run the crashes. So we have fixed it using write ahead log, and then authentication for new AC nodes into K3s. So use join token for that. Here edge cases and failure handling. Prometheus unavailable. If Prometheus is unavailable, it should be used Kubernetes API. So and then we have used idempotency for lambda timeout or like mid crash execution, and here we have used regulator queues for handling failures. And then in here we have spot instance capacity unavailable. So for on-demand, so like if spot instances are unavailable, we should fall back to on-demand instances. And then here we have node provisioning timeout. So here's our result for this application. So that's all for this presentation. Thank you so much.